We're continuing our lecture notes on respiration with pre-Krebs and Krebs. Now, the function of pre-Krebs is to prepare pyruvate, which is formed at the end of glycolysis for Krebs cycle. Now, you'll recall that pyruvate was a 3-carbon compound, but Krebs cycle needs a 2-carbon compound to enter it. So pre-Krebs is going to prepare pyruvate for Krebs cycle by reducing the number of carbons in the compound. So this is what happens. First, we've got to get pyruvate into the mitochondrion. Now, the mitochondrion has an outer membrane and an inner membrane, and embedded in those membranes are channel proteins. And the pyruvate can just pass right through those channel proteins and get into the inner compartment. Once it's in the inner compartment, 2 reactions occur almost at the same time. First, carbon dioxide is cleaved off of pyruvate. And whenever a compound loses carbon dioxide, that process is called decarboxylation. There's another word to remember. Then, pyruvate is oxidized. That means it loses electrons. And in this case, it's going to lose hydrogen electrons, 2 of those, and 1 hydrogen proton. But at the same time that pyruvate is oxidized, NAD, there's our hydrogen bus, is going to receive those electrons, and so NAD is reduced, and it forms another bus for ETC, NADH plus H. Now, pyruvate has been modified into the compound called acetate, but it still can't get into the Krebs cycle. So, acetate is joined to a coenzyme A, and it forms acetyl-CoA. Now, it can be transported to the Krebs cycle, and once it gets to the Krebs cycle, coenzyme A is cleaved off of the compound. It goes back to the cytoplasm and can be reused again, and then the 2-carbon acetate that's left is going to join Krebs cycle.